Number 17, a simple pendulum consists of a mass M attached to a vertical string L. The string is displaced to the right by an angle theta. When the pendulum is released from rest, what is the speed of the ball at the lowest point? So again, with conservation of energy, we could say initial energy is going to be equal to the final energy. Its initial energy would be GPE, and its final energy would be KE. KE has its velocity as a component, which will get us our maximum velocity at the lowest point. We can divide by mass, and we get velocity equals square root 2gh. Well, okay, so we know g, we don't know h. We have to somehow determine what h is, the height that this mass has swung upright. So let's see if we could put a couple of lines in here for reference. We have one there through the middle of the ball, and well, close to the middle of the ball there. And we can say that the height is this area here. All right, from here to here, that's the height. So if we can get that height, then we can plug it into this equation and we go home free. All right, so we know that the string is length L, and the string is not going to change its length when we're up here, when we're at full swing. But now that the length, when it comes up here, the height is going to be length minus the height at this position here, right? Because the length of the string, as it's going up, it's going up to a height of h, so no longer will it have its full length as it did down this point. It's minus the height when it gets to this point, so that would be L minus h. So now we have a relationship. We have an angle. We have a, if we were to look at this, this is a right triangle, so we have a hypotenuse, and we have an adjacent side. So that would be cosine. Cosine theta is going to relate to the adjacent, which is L minus h, over the hypotenuse, which is L. And we somehow want to come up with the height, so we can plug it into our original equation. So we can multiply both sides by L, and we would have L cosine theta, and that's going to be L minus h. We could subtract the L from this side, and we have L cosine theta equals, minus L equals negative h. Let's make h positive, L minus L cosine theta. And since L is common to both terms, we can factor out the L, and we'd have 1 minus cosine theta. So now we have a height. We have a height that's equal to L times a quantity 1 minus cosine theta. We can plug that height in over here, and we would get 2g, velocity is equal to square root 2g times the height, which is L times 1 minus cosine theta, and that would be d.